Okay, today we're going to be talking about and working with a technique that is called completing the square. Completing the square. And what it does is it allows you to factor the completed trinomial as the square of a binomial. So when you're factoring perfect squares, perfect square trinomials, we talked about them earlier. All right, some perfect square trinomials. X squared plus 2x plus 1. It's a perfect square trinomial. First term is perfect square, the last term is a perfect square. This factors to x plus 1 squared. X squared plus, let's see, 4x plus 4. That's another perfect square trinomial. It factors to x plus 2 squared. X squared plus 6x plus 9. All right. So hopefully you can see that when you're dealing or working with perfect square trinomials, they're much easier to factor because their factors are the square of a binomial. X squared plus 8x plus 16. That's x plus 4 squared. Okay, you'll see some in your assignment today. Something like 25x squared plus 10x plus 1. First term is a perfect square, and the last term is a perfect square. So this factors to 5x plus 1 squared. The square root of 25 is 5. The square root of x squared is the x, and the square root of this 1 right here is this 1 right here. All right? 9x squared plus 24x plus 16 again. First term is a perfect square, and so is the last term. And when that happens, this is a perfect square trinomial. So this would factor to 3x plus 4 squared. See it? The, I don't know, not toughest part, but, well, the essential part is recognizing the perfect squares, all right? Recognizing that 25x squared is a perfect square, that 9x squared is a perfect square, and so is 16. And seeing it and not starting the problem and trying to factor it, and creating more work for yourself, as opposed to just seeing it and realizing perfect square, the square root of 25 is 5, square root of 1 is 1, this is 5x plus 1 squared. Makes your life much simpler when you're working with perfect square trinomials. So the technique that we're going to work with today, completing the square, well, we're going to cover that in just a second. Before we get to that, we are going to solve by finding square roots. Okay, so first part of your assignment today, you're going to be given some problems and you're going to be asked to solve by finding square roots. So let's say we got like a 4x squared plus 10 equals 46. All right, when you look at this problem, you've got an x squared, but you don't have anything with just an x after it. All right? When you see that, you get the x's on the left side and you get the regular numbers on the right side. So you solve this like you have been. You subtract 10 from each side. Bless you. You get 4x squared equals 36. You divide both sides by 4. You get x squared is equal to 9. And then you square root both of these. The square root of x squared is equal to x. And the square root of 9, what you have to use here is you have to use positive and negative 3. So those are the solutions to this equation by finding square roots. All right? That means the zeros of this function are at positive and negative 3. The solutions of the function are at positive and negative 3. And the graph of this parabola is going to hit the x-axis at negative 3 and positive 3. All right? So if you get a 7x squared minus 10 equal to 25. Again, you have no term with just an x after it. So we add 10 to each side. And 7x squared is equal to 35. Divide both sides by 7. X squared is equal to 35 divided by 7 is 5. You find the square root of each side, or of both sides. So x is equal to positive or negative square root of 5. And you can finish that by writing this squiggly line, which means approximately. You take 5 and hit the square root button, it's 2.24. So here's your solution in simplest radical form. This is the in simplest radical form. This is obviously as a decimal. So your life will be, well, I don't know. I would just finish it. Once you've got the square root of 5, just type it in your calculator and write the decimal version as well. All right, so there's your solutions to that equation. Those are your zeros. That's where the graph would hit the x-axis. All right, 2x squared plus 9 equals 13. Again, there's no term with just an x after it, so we subtract 9 from each side. 2x squared is going to equal 4. Divide divide both sides by 2. Your x squared is going to be equal to 2. When you square root both sides, your x is going to be equal to the positive or negative square root of 2. And that is going to be equal to positive or negative 1.41. So there's your radical version of the answer and your decimal version of the answer. Okay, then you're going to solve some equations. Going to be solving some equations that are perfect squares. Solving a perfect square trinomial. So here's what we've got. We got an x squared plus a 4x plus a 4, and it's equal to 25. It's important that you notice that this trinomial on the left-hand side is a perfect square. As soon as you realize that, you can factor it. So here's what happens. This x squared plus 4x plus 4 is the same as or is equal to x plus 2 squared. And it's still equal to 25. Now, just like up above, when we had an x squared equal to 2 and we found the square root of both sides, it removed the exponent from the x, didn't it? Well, if you do the same thing to this whole factor on the left, if you square root the whole left side, you have to square root the whole right side. What it does to the left side is it eliminates this exponent. So on the left-hand side of the equation, you're left with x plus 2. And it's equal to the square root of 25, which is positive or negative 5. Now, you've got two equations to solve. You break this apart. You break it apart as x plus 2 is equal to the positive 5. And then the x plus 2 equal to the negative 5. You solve both of those equations to get your zeros. So you subtract 2 from each side on the left, and you get an x equal to 3. You subtract 2 from both sides on the right, and you get x equals negative 7. Those are your two solutions to the equation. Those are your zeros of the function. And that graph will hit the x-axis at negative 7 and positive 3. If we're solving x squared minus 14x plus 49, and it's equal to 25. Be careful over here on the left. You got a perfect square as your first term and a perfect square as your last term, but you got a negative in the middle. That changes your factor to x minus 7 squared, and it's equal to 25 again. So you square root both sides. On the left-hand side, you're left with x minus 7. On the right-hand side, you're left with positive or negative 5. Again, you write your two equations. x minus 7 equals the positive 5, and x minus 7 equals the negative 5. You solve them both. All right, so again, here's your solutions. 2 and 12. Be careful right here. All right. This middle term is negative. This is going to be negative. So we can say that these perfect square trinomials are pretty easy to work with, right? Okay. So there is a technique that's called completing the square. We're going to say this right here. You can form a perfect square trinomial from x squared plus bx plus b over 2 shoot. Don't go that far yet. You can form a perfect square trinomial from x squared plus bx by adding b divided by 2 squared. It's going to make a lot more sense in just a second. X squared plus bx plus b divided by 2 squared is equal to x plus b over 2 squared. Here's what we mean by that. You're going to be asked what value completes the square. You're going to be given an equation like x squared minus 10x. What you need is this value right here. Here's where it comes from. You take half of this term in front of the x, or you take the term in front of the x. You take negative 10. You divide it by 2. And you square it. Okay? That tells you what value completes the square. What's negative 10 divided by 2? Negative 5 squared is 25. So in here goes plus 25. And what you did was you just turned this binomial into a perfect square trinomial. B divided by 2 squared added. B divided by 2 squared added. All right? X squared plus 6x. If we have x squared plus 6x, and we need to complete the square, we take 6 divided by 2 and square it. So we got 3 squared. That's equal to 9. So in here we go plus 9. Make sense? If you got x squared plus 12x and you got to complete the square, you take the 12, you divide it by 2, and you square it. 12 divided by 2 is 6. Squared equals 36. So in here goes a plus 36. If you look back earlier when we were writing these perfect squares, if this leading term is 1, all right? When this leading term is 1, half of 4 is what? 2 squared is 4. Half of 2 is 1 squared is the 1. All right? You see the pattern? Half of the middle term squared equals the third term in a perfect square trinomial. So with that in mind, the last thing you're going to be doing today is you're going to be solving by completing the square. So we are going to solve by completing the square. And right out the gate, we change everything up. We make it a 3x squared minus 12x plus 6 equals 0. And we haven't worked with anything with a leading term other than 1, so now all of a sudden there's a 3 there. But as you're glancing at this problem and you see a 3 and a 12 and a 6, they're all divisible by 3. So the first thing you can do is take both sides of this equation and divide them by 3. And 3x squared divided by 3 is x squared. And negative 12x divided by 3 is negative 4x. 6 divided by 3 is positive 2, and it's equal to 0. Now, do you see how this is not a perfect square? It's not a perfect square, and we're using this completing the square technique. So here, since this isn't a perfect square, let's subtract 2 from each side. Get x squared minus 4x, skip some space, equals negative 2. Now we're going to do that complete the square technique. We're going to complete the square on the left side of this equal sign. We're going to take negative 4, going to divide it by 2, and square it. So we get negative 2. We're going to square it, and negative 2 squared is equal to 4. So if we add 4 to the left-hand side of this equation to make it a perfect square, since we got this equal sign now, if we add 4 to the left side, we got to add 4 to the right side. That's one step that everybody forgets. They remember to add it here. You got to add it to both sides. So now you have created a perfect square on the left-hand side. X squared minus 4x plus 4 factors. This is x minus 2 squared. And it's equal to negative 2 plus 4, which is 2. So we've done problems like this already. And we take the square root of both sides. On the left, we get x minus 2 equals positive or negative square root of 2. Add 2 to each side. Now on the left-hand side, you get your x. On the right-hand side, this plus 2 is not under a radical. So on the right-hand side, we get 2 plus or minus the square root of 2. Now, if you were going to finish this, we go 2 plus square root of 2, and we go 2 minus the square root of 2. So 2 plus 2 square root is 3.41. And 2 minus 2 square root, that's 0.59. So those are your two solutions using completing the square technique. Yes, no, maybe, good. Let's try one more. I'm going to give you some practice. Let's go with x squared plus 10 equals 12x. Now, the 12x is on the wrong side. The 10's on the wrong side. It's not a perfect square. If we started off by subtracting 12x from each side, we get x squared minus 12x plus 10 equals 0. All right, we got no factors that multiply to 10 and add up to negative 12. 10's not a perfect square. But you just learned how to complete the square. So if we subtract the 10, we got x squared minus 12x equal to negative 10. And you know how to complete the square. So if we take this negative 12, divide it by 2, and square it, we get negative 6 squared, which is 36. And using the complete the square technique, if we add 36 to the left, we can add 36 to the right. The left-hand side is now a perfect square trinomial, and its factor is x minus 6 squared. And it's equal to negative 10 plus 36, which is 26. So if you square both sides, on the left we get x minus 6, and on the right we get positive or negative square root of 26. Add 6 to each side. Our x is equal to 6 plus or minus the square root of 26. All right, so we take 6 plus 26 square root. It's 11.1. And then we take 6 minus 26 square root. And that's 0.9. And those are your two solutions. Good? Pretty simple, right? In a way. All right, you e-learners, your practice page has been uploaded to the resources tab on Focus. It's there for you to access. Send me a picture of your work when you're done. I probably should give you the assignment, right? That would make sense. Your practice problems today are going to be on page 237. Page 237, let's go 12 through 17. And 19 through 39. And this is going in the basket, or you're going to email a picture. That's coming to me. The rest of you guys, you can access the page on Focus, or I'm going to put it up on the wall and you can take a picture of it. Either or. If you e-learners don't have any questions, I'm going to end the meeting at this time.